Okay, so in this tutorial, I'm going to show you guys how to make a very basic vehicle class and associated object. And there's also going to be a bit of a justification for why I chose to use the coordinate frame from the last video. So I'll start with the justification just because I already have it up and it's fresh in my head right now. So if you remember from the last video, I made the assumption that, you know, we will be sticking with we'll be using the latitude line and then we will be sticking with it. And we'll be defining our coordinate frame from there, right? So we would have our z hat going this way, our y hat going this way, and x is into the page. And, obviously, if you rotate by, you know, by a certain amount, right? Or rather, if you move by a certain amount on the Earth's surface, you actually have a new reference frame, which, this won't be the same one as the first one here. And today is just going, and this little justification is just, to see, is this valid for our application? And as I already mentioned, we're modeling a kinetic vehicle, which is a fancy way of saying it's going to be a projectile, right? Something that obeys the ballistics equation. And, let's use, just a typical range, right? Of, an upper limit would be maybe like 100 kilometers, right? For our purposes, right? Obviously, if you're designing actual long-range missiles, you'll have to use a different system. But for us, we're only looking at, let's say, like, one, one latitude degree. One latitude degree, right? That would be like our little bubble. And we're gonna see, like, what is the error associated with this. So 1 latitude degree, if you go to Google, you'll just find out it's roughly 100 kilometers, right? Or 111,000 meters, right? So this is the number we're looking at for, our range. And so let's say we move that much in our range, right? So we're going to do it in green. So let's say we go that many kilometers in a direction. Okay, well, we can figure out our goal is to figure out, what is this error right here, right? And the easiest way to do it is, just we have the radius of the Earth here, which is 6,371 kilometers, roughly. Um, and we have a right angle here, right? Because we've defined up and everything from here. And so, this would be 111 kilometers. And so, we can easily use the Pythagorean theorem to solve for this side right here, right? And this side's just going to be the square root of the radius of the Earth squared plus 111 kilometers squared. I don't need to put kilometers there, squared. And a bit more of a useful way of writing this would be the radius of the Earth, square root 1 plus 111 divided by radius of the Earth, all of this squared, right? And so you can see, like, from here alone, you know this is going to be a small value, right? This is not going to change very much. But, just to be sure, we'll solve for this value. And this is just going to be equal to the radius of the Earth minus this right here. And so let's just do that. Minus RE square root 1 plus 111 over radius of the Earth squared, and the whole thing is square rooted. And if we, just simplify a little bit, we get 1 minus the square root of 1 plus 111 over radius of the Earth, all of this squared. And so as you can see, if this value is very small, then this is just going to be 1 minus the square root of 1, which is 0. And so virtually this amount would be the same as this. But obviously, we're not going to, rely on faith. We're just going to shove this into a calculator. And that's exactly what I've done here. Radius of the Earth, this is all in kilometers. And so we see that we get a value that's less than 1 kilometer. And so what this means is this value right here is less than a kilometer, is less than 1 kilometer, right? And so if we look at, like, like what that error means, right? It means that if we move by 100 kilometers in a certain direction, our error is going to be a single kilometer. And from the graphs that we had yesterday, we were on the order of like 50 meters, right? Everything we did was in meters, and we were off by 50 meters. So 50 meters, it really is going to make a difference of like maybe a few centimeters, maybe a whole meter, right? And so that's perfectly fine for the projects that we're working on, right? If, assuming we're trying to hit a target, if we're off by a meter, as long as, we're not trying to, like, do some precision striking, that's more than acceptable, right? And so that's just the justification for now. is that we can get away with this. Obviously, if we were doing, a large space-based system, we were trying to intercept, an ICBM or something like that, we would definitely have to change reference frames. We'd have to use like, spherical coordinates like I was going to do, but then dissuade away from. Depending on, whether or not this project takes off, I may actually switch back and I may go back and revise that coordinate system. But for now, we'll leave it as is, right? We'll use this system, provided that we keep in mind that this is our error. We should not be going anywhere near 100 kilometers, and whatever error we get should be roughly 1%. So now that that's done, we can look into the vehicle class stuff. I'll just move this off here. It's whatever. Okay. So first of all, you guys are very lucky that I had to suffer through this myself. If you look into my history, you can see it. There's just me making errors all over the place. You guys get to avoid that, and I get to show you how this all works in the end. I show you a clean result, not all the dirty stuff. But just know that I sat here for 3 hours. And so, if it looks, as like a future reference, if it looks like I do these on the first try, that's rarely the case. I usually spend hours here before recording a 30-minute video. And it's usually for finding small mistakes. So, yeah. All right. Anyway, let's get into it. So, a vehicle class. Well, let's just see what happens if we make a class, right? New class, and we'll call it vehicle. And obviously I have my reference over here on the side, so I won't be making mistakes, hopefully. But if you guys were to do this in the future, definitely try playing around before you do. So we've made our vehicle class. You may be wondering what this is. This handle basically says that it's a handle class rather than a value class. The noticeable difference is just that one of them is editable, you could say. Let me just do this handle versus value class MATLAB. You can see I've already been here, but the idea is basically that a value class, you really don't want to you should avoid changing stuff. Versus in a handle class, it's very easy to just constantly change things around, and it makes it easier, you could say. Also, if you ever decide to try and animate your stuff, it's a lot easier to do it in a handle class. And somewhere further down the line, when we start doing attitude dynamics, we'll definitely be modifying our drawing images. Summary of the vehicle goes here. I don't put anything. I just get rid of this. Add in a few more comments. Okay, so what are the properties that we care about? Well, the purpose of a class is just to store the data as an object, right? We're creating a virtual object that's going to be representative of our system. And so for us, right, what are the main properties that we care about? Well, we care about, the time span, right, because that's important. We care about the time step, right, that's important for our numerical integration. For this specific class, we also care about latitude and mass. I almost said longitude. And we also care about the initial state and the simulated state, which I'll call SI and SS. For now, I'm not going to leave, actually, I'll leave some comments. Let's do this. So this is time span, this is time step, this is mass, and soon we're gonna have to change this mass, right, when we start accounting for like a rocket per se. We have our initial state vector, and then we have our simulated state vector. Yes, there we go. And finally, because it's a handle class, right, we can add in this little parameter here, h, which is just a fancy way of telling MATLAB, like, hey, if we ever want to reference this specific object within, its own class, which we would do in like a method, let's say, we can just pass the parameter h, and it will know immediately we're referencing the same object. This won't be useful right now, but you'll see when it comes in handy when we start doing attitude animations. Anyway, the first thing we have is the constructor. So this is just to create, the class, and to create the class, we just have to pass in the inputs that we care about. So we have to put in a time span. We have to put in a time step. You know what? I'm going to move the command window down just because we don't need it right now. We also want to pass in the mass, the latitude, and the state I vector. Yeah. All right. Let me get rid of this and detailed explanation. Create a vehicle. There we go. And so now we just have to assign these properties to these inputs, right? So obj dot time, or sorry, tspan equals tspan, obj dot dt equals dt, obj dot mass equals mass, obj dot latitude equals latitude, and then obj dot state I equals state I. And then remember how we had to define this, the x span in here, right? We literally we use this exact format, right? Length of the t-span and columns is the size of this. So object dot state s is equal to zeros, and then length t-span, and then length state I. Yeah, there we go. So now we will have the length of our time span vector is the number of rows, and the columns will have all the different state variables. And so that's pretty straightforward. The next thing that we need to do is set up two methods. I'm going to do, I'll just keep them for now. So the first thing that we have is the vehicle dynamics, right? Vehicle dynamics. And so this is just going to be, how does our vehicle change, right? We want to have everything under a single main function, right? Or at least that's how I like to do it. And then from here we can expand and add other dynamics if we felt like it. But for now we only have the one that we made last time. So this is I'll just vehicle system dynamics. This is the name I use. You can use whatever you want. And this falls under vehicle dynamics. Okay, so for the vehicle dynamics, it's going to be it's going to be exactly the same as our equations of motion for now. So the way we should have it as an input is, first we want to pass in the object itself, right? We want to be able to reference these properties, like especially like mass and latitude if we ever need to. We also need to care about the current time. That's pretty important. We also need to care about the state of our vehicle, and we also care about the, whoops, my apologies, I will mute this right now. So yeah, we care about the object itself, right? We want to pass the parameters from the object. We want to pass in the current time, right? Just in case we have some time dependence going on. We also want to pass in the state of our, of where our vehicle is right now. And we also want to pass in the index. And you'll see why this is going to create a massive problem, right? Because this is the thing that we're going to feed into our RK4 solver, right? Our Runge-Kutta solver. Let me pull that one up once again. And as you can see here, we don't actually pass in an object to itself, right? Our dynamics don't really care about, what object is going into it. But as you can see, we're going to have to modify this function a little bit to include, a dynamic that is within an object. And we're going to do that, and this was the annoying thing, right? This is what took me, several hours to do. It's because I just couldn't. It took me a very long time to find it. You guys don't have to worry about that. So let me scroll down in my thing. Okay, so what are the dynamics? Well, let's do this. We know that the change in our state, first of all, it has to be the same size as our as our state vector, right? So obj.state I. Or we could use state I is just something that's a fixed value, so I personally prefer to reference that. Let's do this. 1, comma, actually no, we don't need to do that yet, right? We're just setting it up. 1 and then length, whoops, not object, length object.state I. Okay, so we have that. I'll just leave myself a little bit of space so I have some room to type. So what exactly is this d-state vector going to be? Well, as before, it's going to be, there's going to be a size of 6, right? That's just the way we have it set up here. 6 state variables. And what are these variables going to be? Well, there's just going to be what the, how the state would change. And that's governed by our equations of motion. So gravity, EOM, right? And what we're going to give it as an input, right? What does gravity EOM take as an input? Let's pull it up. Let's see here, plotting functions, gravity EOM. So gravity EOM takes in these inputs. And I'll copy this over just so I don't make any mistakes here. So let's see here. We have so the first thing that we feed it is time, right? The second thing we feed it is this current state. Next thing we feed it is the mass, which would be obj.mass, and then we also have to feed it the latitude, obj.latitude, right? And this is why we would have to reference our obj. I don't know why, but you have to have it be the first input. That's just the way MATLAB is. I have no idea why, and I don't have the patience to go and find the answer to that. If you do find the answer, leave it in the comments. I really want to know because that has caused me so many problems in the past. Anyway, so yeah, this will be our d-state vector. It's just going to be that. And obviously that's also going to be our output, so we want to put that here. And that's pretty straightforward. Yeah. So the next function that we have to create, or the next method that we have to create, is the simulate one. Simulate, and we want to feed it the object itself. And at the very end of this, yeah, there we go. So what is this method going to do? This will be the simulate method, and this will simulate system dynamics. So how does this do this? Well, first of all, we have to tell it what the first variable is, right? So simulated state S, the first row, every column is going to be the object state I, right? We know that. That's just code that we had from our previous file. Next, we have to go through and iterate through all the steps. So this is a length obj.tspan -1, right? End. And then this is, same thing as before, right? Obj state S a+1 comma all the columns is equal to rk4. We want to feed it in the obj.vehicle dynamics, and into this, remember, we ignored the first thing, right? This is just something that the class itself needs to know that we are in fact feeding an object into itself. And so the actual input would be these three variables right here: t, state, and current index. So to feed it time, we do obj.tspan a, right? Then we have to feed it the time step, for vehicle dynamics, we have to feed it in this. This is RK4. My apologies. For RK4, and you can see why this created problems for me for hours. For RK4, this is the input format that we need. So let me just do a comment and put it in here. This is how RK4 expects us to feed it the inputs. First, it expects the dynamics, right? We're doing obj.vehicle dynamics. We're feeding it in this value up here, this function up there. Then we have to put in the current time, which is tspan a, right? That's a is the index. Time span will tell us which one it is. Then we have to feed it dt, so obj.dt. Then we have to feed it in the previous step. So this would be obj.state s a comma everything, right? And then we feed it the variable arguments that that go in later. So what other variable arguments do we need? Well, vehicle dynamics, for that, the variable inputs are a, right? We care about the index per se. And this, right now, we don't need this index, but when we start doing stuff with controls, a is very convenient for putting in guaranteed actions at a certain time, right? It's just easier. It'll make my life easier in the future. That's why I do it. Let me just make this a little cleaner. Okay. So now you can see that our RK4 is doing things in a little bit of a weird way, right? In that, RK4 is expected to feed dynamics, time, dt, current state, and the variable arguments in. However, our dynamics has to first take in an object, a time, a state, and the letter, and the index. Now, what does this mean? What this means is that our RK4 function, this right here, needs to be able to take in the object itself. And so we're just going to add that in right here. We're going to add it in after the state vector, so that we don't have to go back and change all of our code. We can just put obj as the first thing. If we're not dealing with an object, you would just put a dummy variable in here. You put like 0 or 1 because your dynamics function would no longer care about it. However, because of the way things are, we do have to care about it, and so we will feed it in right here. obj, and then obj. Yeah. So, just to make this, hopefully I'm doing this right. This causes me great pain, but let's see. For our dynamics, we are feeding it in the object, time span, state, and A. In vehicle dynamics, we are only feeding it in these values right here. Right? Yes. And then in RK4, we are feeding in everything from before, plus the object and the variable argument out. And this should resolve the error. If it doesn't, it's going to be a very long video and we're going to have to debug it all. But that's no big deal. So, all right, let's edit this file now and, you know, slowly do stuff. So we have our mass, we already have our initial state vector. We don't need the solution span anymore. Now we make a thing in here called vehicle class or vehicle object. And I'm very creative with my names. I just use capital letters because that helps me distinguish between you know, what are functions and what are objects. So let's go in there, copy this in. T-span is T-span, dt is dt, mass is m, latitude is latitude, state I is going to be x naught. And then we don't really need a solver anymore. Now we can just do vehicle.simulate, and this should simulate the vehicle. And then instead of you know, plotting our things directly, we can just we would just add in vehicle.state s, and then we would repeat that for all the other ones as well. Control V, Control save, and this should be about right. It's likely that I made an error in here, but we're about to find out. Run this only. Boom. Okay. Errors. Okay. Yes. First thing, we have to add this to our path, right? We have to add path, gen path, and this time we put it in src, so we'll just do src. Close this off. Let's see how this goes now. Wow, that actually worked on the first try. You know, I might have been copying it, but I am still surprised that it actually worked. Anyway, yeah, it's a very annoying process. I assure you, this is not very fun to deal with. I am genuinely surprised that this actually worked on the first try. But if you have any errors, right? Let's say, you know, you forget something and it keeps telling you stuff like the kinds of errors that you'll get are going to be things like, you know, you know, you didn't have any input arguments, or you can't multiply class vehicle, or you can't add class vehicle. You'll get errors like that. And the easiest way to know whether or not you know, still have any errors is by quite literally plotting, or not plotting, but displaying everything, right? That's the best way to, you know, to diagnose your problems. Personally, this is the kind of stuff I was doing. Yeah, you're about to see a master debugging process here. I'll just copy a display function a bunch of times. First thing I want to display, object. I'll display the object variable. Second thing I want to see is the current time. Display t. Next thing I want to see is the state, and I'll display the state variable. Next thing I want to see is the index, and I'll display the index, which is a. And when you run this, and press Control C to stop it, because it will run crazy, is to go back and make sure that these are, the values that you expect them to be, right? So like here, index, or sorry, we'll start here. Object, right? Obviously, this is our vehicle, right? This is what we expect it to be. We expect it to be the vehicle itself. We have the current time, 0.29 seconds, okay. We have the current state vector. It hasn't changed much, right? As expected, this thing just launched. And then we have our index, which is a 29th index. And you might be wondering, why does it repeat 4 times, right? We have index 29, index 29, index 30, right? If you see it, index 30 will repeat 1, 2, 3, 4 times. And the reason why it repeats 4 times is because of our RK4 solver, right? Our RK4 solver solves these things 4 times, right? It needs to do 4 different things. And on each of these iterations, we're printing out all of these values. This is a very complicated thing. It's easy to make mistakes. The best way to diagnose these problems is by, constantly printing your values. And this is how you do it. It's a little tedious. It's a little annoying, I assure you. Odds are you won't get it right on the first try. I know I didn't. If I recorded these without thinking, we would probably be here for hours. But this is an easy way to diagnose your problems, right? You do this. You maybe run one within RK4 to make sure that these are actually the inputs that you expect them to be. Let's see if this works. I haven't actually done this specific one yet, but let's see. It should display the whether the dynamics actually as well now. So let's see here. At the start of, there we go. Yeah. So we're making sure that our input or the function that we're looking at is in fact the vehicle dynamics function. We could repeat the same with the rest of these as well. And what you'll find out is that they are actually what you expect them to be. Yeah. Okay. That's an intro to debugging, quick intro to classes, as well as the justification I did at the very beginning. Okay. This video is already 30 minutes long. Yeah. In the next video, let me just pull up my tentative schedule for these. So yeah, so we finished vehicle class, and the next one is going to be doing rotations, and we're going to be doing them in quaternions. So yeah, basically we're going to expand on these state vectors to now include rotations. All right, that should be out tomorrow or the day after. That's it for this video. Goodbye, don't give up, have fun debugging.